that we're going to be making use of off-the-shelf components for all of these. So the FSR is not something that would be included in this particular sheet. So if we go on to the touch sensor, the idea was to base this on a little 6-pin touch sensor device, the type of thing that TI or Microchip and others provide. Is that the type of approach you were thinking of, Rob?
Yeah, that would be fine.
Yeah.
This is the first pass. Yeah, for sure. This is the first pass. Save time.
Yeah.
Don't redesign.
Yeah. And these are, I must admit, I haven't seen the modules you've sent in. They're in the office. Adrian has them. I don't know what you're using on your current one, but probably something similar, is it?
For the FSR?
For the capacitive touch.
We are not really using. We don't really have a cap touch module. It works with an NPN that turns circuits into touch circuits, but technically speaking, that's not cap touch. That's voltage being able to pass through the human body.
Yes, sure. Okay. So are we going a bit too sophisticated here? Is this not for the touch sensor? Would you want something like this? I mean, it's a relatively cheap part, but it does need a few passives around it. It would be possible to do it, but it could also just be the transistor, as you say.
So here's the thing. The FSR could be the version of potentiometer. You might have to hold your hand on it, but it could be the potentiometer.
That was one of the options I think that Adrian put further down.
At the top, FSR and touch sensor are both right at the top of the spreadsheet.
Oh, this one here, yeah. So yeah, that would be possible to use as a variable resistor for sure. What functionality do you want for the touch sensor though? Is using the input to a transistor sufficient, or would you rather have a controlled capacitive touch device?
Well, I think that they're going to behave exactly the same way. The difference with a cap touch is you might be able to get a proximity sensing ability, but I think that might draw a bit of power for it to be able to, detect changes in the E field around the module. I think that may be going further than what we originally intended.
Recently,
and having a module that
power.
Yeah. Are you typing into notes? I actually don't see anything changing on the screen, including myself.
No, we're not. I'm not typing into the spreadsheet.
Okay.
So do you think that's probably unnecessary, and you could simply use the transistor module as the touch input, as it currently does?
So here's the thing. Here's something to think about. The transistor module, the transistor can be a momentary switch, if you will. Power ground and out. The like a latching switch could be very similar, like use the same principle to detect a touch, but then could latch and might need that either is flip-flops or creating a sort of a DIY Schmidt trigger, or it's a teeny tiny micro.
So there's a switch device. I mean, so Adrian's come up with a number of different switch options. So there's the capacitive touch one, which is a TI part. There's a dome switch, which is just a little dome type switch that you get inside membrane key switches, that type of thing.
Yep.
So that's press and a click and makes a contact. That's momentary, obviously. On row 7 here, we've got a slide switch, which is actually an extremely thin, low profile. How big was that device, Adrian?
Let me double check.
AYZ0202A garlic. Farnell.
It's quite an expensive part.
Yeah, and it says high risk of falling off.
I think it was the order of 0.5 millimeter thick, or was it 0.7 or no? Maybe it's 1.1. That one, 1.5. Okay, 1.5. Yeah, sorry, getting carried away there. So clearly that's a standard switch. Would that be something that you could use as a two-state switch that would be simple for the people to use, or is that too bulky, too expensive?
Let's take a look at it. Okay. Farnell, what was it? AYZ0202AGRL.
You should be able to click the link yourself in the Excel sheet.
Yeah, I'm just on one screen and I'm looking at your screen instead of opening Excel.
All right.
Okay, I see it. Yeah, that's a tiny little switch. Those are nice.
It's pretty smart.
Yeah, but would that just pop off?
Yeah, I mean, there is sort of risk certainly of I mean, with all of these, we'll have to make use of non-conducting adhesive as well as conducting adhesives to attach. That one, as Adrian noted here, could be a risk of the thing coming off.
Here's the thing. That's pretty easy. That's a pretty easy, like, hey, let's just make this. You know?
Yeah,
I would just make a bunch of those and see. Let's see, where's the price break? It's still $1 at 300. 6,000 at 73 cents. I mean, there's a lot going on inside of a little switch like that. Folded sheet metal, spring steel,
sure,
injection molded,
yeah.
multiple plastic parts. So yeah, we would only give people one of those if we did that at all. I think that since that part is relatively easy to just buy and the footprint is pretty simple and there's no circuitry involved, I think that you should prototype it.
Okay.
Yeah, I mean, that would be one that you could just sort of make really quickly. One of your simplest ones.
Yeah, sure.
And then, you know, a dome switch, a momentary dome switch could also be a 2 in, 2 out.
This one actually wasn't the dome switch, was it, Adrian? It was. It is actually an encapsulated proper switch, but incredibly thin.
Okay.
Sorry, I misled you there. I was thinking, so it's this type of thing.
I turned off my video to save some bandwidth, but yep, there you go.
Okay.
A little dome.
It's only 0.55 thick,
Yeah.
5mm square essentially. But it is mounted on a carrier, so it's not just the
Right.
dome itself.
Right.
I mean, that one's pretty cheap. These are UK pounds, of course, so apologies for that.
Oh, okay. Mm-hmm. Right. We talked about making a dome switch, and I think that that's also another sort of basic one to see if you can make it and have it hold down. So it's not there's not really a circuit design. It's just, can we put a couple traces coming out of the leads and get this thing to stay down? It's a fingernail switch, right? I mean, will that work with the pad of someone's hand, or do you need to push that with your fingernail? I'm guessing without anything over it, it's a fingernail switch.
Yeah, it's 4mm diameter, so it's a bit more than 1/8 of an inch. Fairly small for sure.
Yeah. All right. I've got my calipers. Let's take a look at what that looks like. Oh, that is tiny.
Probably too small.
What is the force required to make it actuate? Newton. 1 Newton? Depends on the model. I would get the lowest force. Travel 0.15 millimeter. Yeah. Yeah.
That's around 1/8 of an inch diameter, isn't it? It's about 3.5 mil.
I didn't follow that, but I can see your screen. It's a tiny little switch.
Yeah, I mean it's about 1/8 of an inch diameter, I guess.
Yeah, I actually, so I turned
4.8
off my
millimeters.
video, but I have a digital caliper up right in front of me, and I pulled out 4mm just to look at what that would be. That's very, very small. I mean, it's an appropriate size for a sticker, but with something that small and without a mechanical force multiplier on top of it, you're going to want to use the lowest operating force.
Yep.
Option. I mean, which is ironically scarbage. The scarbage switch.
It's garbage.
Minimum order 10,000.
Again, a simple one to build if you want us to try it. It's a simple one to build if you want us to try it. But if you think it's really just too small to be useful,
right, you can get dome switches bigger than that. But that was on. I'm not familiar with that site, so it said minimum order 10,000. Are you able to get onesies?
Yeah. Yes, we can. Yeah. RS components have everything from one-offs.
Okay, what is RF components? Is that British?
They are, but they're international too.
Yeah.
Yeah, now RS is selling it back to 10, so pretty cheap.
What was the URL for? I guess I could click on it, but I don't have it open. So RF components is what? When I search for that, I just get all these RF components.
The ones we're looking at are uk.rs-components.com. online.com.
Okay. Let's go into the document myself. This will save some trouble.
And if you search for
I'm in it now.
the part number, you can see on the screen there. Okay.
Okay. Okay. So let's do. Let's go to DigiKey real fast. Dome. Switch. Tack. Okay. Optical snap switches.
I mean, there are larger ones that we've seen. I mean, there was a simple dome, a bare dome switch, if you like, that I think was probably larger than that, and you can certainly get them larger than that. And if you'd like us to look for a larger, say, 10 mil diameter, something like that, 10 millimeter diameter switch, that would be possible to do.
Yeah. When I went into push button switches, is this gonna work in DigiKey? Let me see. They start at 12 millimeter, so I may not have the right setup. I want surface mount. Yeah, none of these are right. So let's go back. Tactile switches. Surface mount. And active part. And apply filters. Okay, let's filter by dimensions. By 12, so let's look at this. Okay, that's too big. Okay, so here's a big one. 54 cents. These
and
are
the nice thing about this one is it is very low profile. It's a key thing, really.
No top actuated surface mount. Okay. So we need it to have a base.
I mean, if you'd like us to have a look for that, Rob, and see what we can find, rather than
do it now,
spend too much time on that one.
Yeah. Yep.
We could do that. So, can we find 10, 12 millimeters? But presumably the price point has still got to be pretty low. I mean, your whole cost for this is.
The point is cost reduction versus.
Yeah.
The standard magnetic modules.
Yeah, sure.
Cut tape digireel.
Okay, so we'll have a look for that.
Okay.
I don't think we'll find a smaller double latching slide switch than the one that Adrian found. So
right, that is a
size,
very small
that's probably
component.
the smallest.
Yeah.
And if you want us to try that one, we'll give that a go. As we said, it's very, as you pointed out, there's a bit of risk in terms of mechanical assembly, but it's worth a try.
Yeah, it may be better to just use something that's touch sensitive that turns on and off. Latches.
Yeah, which for example, this could do. I mean, there is a latching version of these. I'm sure there's a latching version of these TI capacitive switches, touch to set and touch to reset.
Let's look at that guy.
Would you be looking for all of these types of switch, or is one of these sufficient, or do you want a momentary and a latching? Presumably, there's no point in having.
I think having a momentary and a latching would be a good proof of concept.
And in terms of the momentary, it could either be electronic touch switch, or it could be a mechanical dome type switch.
Right.
If we can find one. Okay.
And what would be really interesting is if they use the same component, then our economies of scale are helped out.
Yep. Sure.
Let's click on this Farnell data sheet. So I'm looking at the microchip component. It does prox and touch. 1.8 volts up to 5.5. 17 microamps at 1.8 volts is typical. Okay. 6-pin SOT236 or 8-pin UDFN. Let's look at a UDFN package. How big is that?
Yeah, I think Adrian thought the UDFN was the better option. I think here, we SOT23 are okay, but I think we generally prefer devices where the pads are on the underside. It makes the assembly sort of more robust, rather than standoff pins that the SOT has. Either work, but if you've got a choice, we would, I think, tend to go for UDFN or QFN.
UDFN. Let's take a look at this. 8. View details. Oh yeah, there you go. Leadless. And you have a pick and place that can do these, or you would do it by hand?
We have basically, I mean, for these, we would be doing it by hand, possibly, or we have a pick and place that could do this, either a hand operated pick and place or the proper machine.
Okay. You have one of those pick and place machines where you sort of hold a little joystick with one hand and you move it around and it helps you put things straight up and down?
Yeah, we've got a little manual device which is really quite nice, a Fritsch device which has got a split field viewer, so you can see the bottom of the chip and the top of the chip simultaneously, or top of the board.
Oh, nice!
So that you can align these things quite nicely. Yeah, it's fun.
Wow.
So for assemblies where we're doing 10 or 20 or a few tens, then that's what we use. We've also got 2 pick and place machines. Got a Europlacer and a Yamaha that would be used for any sort of volume assembly.
Okay, cool.
Yeah. Okay, so we'll identify. We'll look for a larger dome switch if there is such a thing that would work. If not, we'll go with the capacitive touch sensor. as an on-off, and we'll also look to see if there is a latching version of that to give you the equivalent of the double slide switch.
Okay.
Okay.
Yep.
Tucked in the middle here is the light sensor.
Mm-hmm.
So this is just a little phototransistor in a very smart, compact little package. I'll show you that. It's a neat little device. And it eventually starts up. That's it. There we go. It's quite high. It's about 1.1 millimeters high. Pretty simple phototransistor. So I imagine we would be including a transistor on this one. Well, possibly including a transistor on this. Depends on the current we get out of it. So this would be about a millimeter high, 1.1 millimeters high.
Yeah, tactile.
Is that sort of... Yeah, I mean, is that sort of profile okay for this sheet?
So you guys are the experts on this. I'm not sure how flexible the stickers will be. If you think that let me see if I can make it quieter in here. If you think that will stay on, then that's great. I don't see anything wrong with that. It's nice and small. A millimeter or a millimeter and a half tall is not very tall. I mean, for an active component. Semi-active.
Oh, that's what I would say as well, but it's surprising how many clients say, that's a great big lump on this circuit, you know, but it's 0.6 millimeters high, but they still think that's too much, you know. So it's good to know that a millimeter is... I mean, in terms of strength, this would be fine. I think it's a small component, 3 millimeters square, roughly 3 by 2.7. We would put non-conducting adhesive around the outside to secure it. It would be pretty secure, I think, this one.
Okay.
Don't think any concerns about that.
I mean, you could even theoretically put a glop of something clear just right on the top of it and let it glop over it.
You could. We tend to draw a trace of adhesive around the component itself, so that it just seals around the edge rather than going over the top again increases the thickness and the bulk of the thing. So
that's cool.
Just going around the side, yeah, that works. There's a robot dispense on these machines.
Wow.
That lets you do that.
That sounds amazing.
So, so we'd like to try that one.
Mm-hmm.
The potentiometer, variable resistor wireless, it is a potentiometer. This is, again, a pretty low profile device that Adrian found.
Borns. I like Borns. Wow, that's tiny. But how would we actuate that?
So they would have to use a little
you'd have to stick something on it.
Tool.
Yeah.
You'd have to give them either that or an adjuster pot tool.
Mm-hmm.
It's 2 millimeters high, 2.1 high, quite large. 11 by about 11 square, something like that.
I think this would have to have... I don't see a really big use case for this one.
No? Okay.
I mean, you're not going to drive a motor with the sticker set.
Yeah.
So if you're going to use motors, which is something that is really helpful to use a potentiometer with, you're going into the magnetic module ecosystem. And if you're going there, then you can use a full-size potentiometer.
Yeah.
This to me is really tricky. I mean, I don't see us like shipping this with a little wheel that you snap onto the module once it's been adhered.
No, that wouldn't be very convenient, would it? Okay.
Yeah, this one might not. I don't know. I don't know if Melbs, if you're listening in, but I'm not so sure about having a teeny tiny, very hard to actuate potentiometer.
No, I am listening in, and I think the product needs to be framed for who the customer is, which is children ages 8 to 13 primarily, but as low as 5. So the less sort of choking hazards and easy to manipulate, the better.
There you go. So touch, but not finger twist.
Okay, so we won't do that one. There's a RGB LED that is again pretty low profile, small device.
I'm opening the data sheet on my side.
No, not on mine.
Okay. Yep. That's great.
I mean, it's a very small device. How big was this one, Adrian? Do you have the data sheet? Oh, it's
as 8 millimeter.
So it's 6 millimeter square, I think, and pretty low profile again, if I recall. 4 terminal. I mean, look pretty good, that one.
Here we go. Yeah, that is tiny. I mean, the pads for the footprint are... The square that contains all 4 pads is 1.5 by 2.3 millimeters.
Yeah.
Wow, that is tiny.
But assembly of that is okay.
You can assemble that.
Sorry, Adrian?
Yeah.
Okay.
Yeah, for those sort of components, we use anisotropic adhesive and essentially just put a blob of the adhesive underneath the component.
Mm-hmm.
And then as long as you've got the alignment, which the pick and place can do, then it works well.
So you've got a liquid anisotropic conductive adhesive?
We use anisotropic conducting adhesive for that sort of device where the pitch is really fine.
Yeah.
We use anisotropic and it works well.
Okay.
So I think we'd have to for that one.
And it doesn't cross talk between there's only a tiny difference between the pads, which is 0.2 millimeters of clearance.
Yeah. Yeah.
Yep.
And the adhesive doesn't leak through something that small?
No, it's smart. It's a really neat little technology. It uses these conducting spheres inside the epoxy that are quite sparse, and so they conduct vertically, but they don't short between themselves. So yeah, it's a nice material.
Yeah, I've used tape like that, but I've never used a liquid.
Okay, yeah. We use that for quite a lot of assemblies.
Okay. Awesome.
So we can go with that one?
I think so. It's very small.
Is it too small? And there was a larger one I think you had, wasn't there, Adrian? Do you want this to be a component that the children can see, rather than just a speck of dust?
Yeah. So here's the thing. If there's another one that's really flat, great. But I think this is going to be one of the most, because you could use this for the bi-LED too. This might be the most commonly used component. Finding something that just works could be great. And by saving a little space by having a tiny module, you can then illustrate in silver silkscreen essentially what this module is. Right? It leaves room to draw a picture around it and make it look like a sun, or literally write the words RGB on it.
Right. Yeah. 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 You certainly could. With these things being so small.
You know, R, like show the common and then show RGB, show the pads, put the letters down, or even write the words red, green, blue.
Yeah.
If people can see that, people might not be able to see it if it's written out. I don't know. Little kids probably could see it. Parents might not be able to read it.
Yeah, that's the trouble. But yeah, I think the kids could see it. Yeah. There would be space for sure to put some text and explanation on.
Mm-hmm.
I'm sure that would be feasible. Yeah.
Yeah, I like it. It's
so
very small. Yeah.
We'll give this one a go. See what that looks like. Then, as far as the sort of standard LED or the bidirectional LED, there was a single package device that Adrian found. This KPB one.
King Bright.
Yeah. But it's quite quite chunky in that it's 1.1 millimeters high.
Yeah.
It's not that big. I guess we're used to clients really wanting the smallest possible. This is 2 by 1.25 and 1.1 high. That's one option, or you could use 2 standard 603s, which would be thinner. They would certainly be thinner. They'll be about 0.2, 0.3 millimeters high. No, 0.4.
Yeah,
Certainly lower than 1.1. Yeah, right. So either of these would work. It's really a case of. I have a suspicion that the 2 standard LEDs would be lower cost ultimately as well.
Then the RGB.
Than the bidirectional. So this is just a 2-color one. This one. So the RGB is one option, but then also Adrian's put in a 2-color bidirectional. And there's 2 options for that. So this is rows 10 and 11 if you're not watching if you've not got that on the screen.
I'm looking at something different. I'm looking at a chart of passive sizes. I'm back to the projection screen now.
Okay. So we've got this one, the RGB, which is the very small RGB LED, and then there's 2 options for a standard single LED, bidirectional LED, which is 2-color. So that would be red and blue or whatever colors you choose. But this single package device is one good option, but this would be thinner. This would be flatter. Option is row 11.
Okay, let's click on that. The 603 seems doable. Oh, there's no data sheet though, so.
Sorry, there's no data sheet, but yeah, that's just the standard, bog standard 0603.
Just using
what sort
2
of height,
LEDs,
Adrian?
yeah.
5.4?
Yeah.
Yeah, using 2 LEDs. Is that what you do currently?
I think it depends on the generation of module you're looking at.
Right.
It's in the let's take a look at this. It's in the Eagle files. I'm opening the schematic for the BiLED right now.
Okay.
It's just a RGB LED with only 2 being used.
Oh, okay. Right. Yeah.
Yep.
Depends how price sensitive you are, I guess.
So this is version 2. Let's see if there's a older version. Let's look at the actual modules I have in front of me. Okay, let's. Where's there? I'm gonna try this again. Let's find a group of all your email address or whoever you want me to send it to. Let's look in the emails for that.
If you send it to adrian.wong at uk-cpi.com.
Okay, let's do this again. Anyone else? Simon?
Yes, send it to me, simon.johnson.
Okay.
And then probably CCing Jonathan as well, just in case.
Okay. Let's grab a couple of these. Okay. Adrian, Jonathan, Steven, Simon. Let's try this again. So, create link.
It's fine by me. Okay, right, we'll do that.
Copy. And paste. Message sent.
Okay, see if it makes it across. So so you currently have a separate RGB and a bidirectional one, but the bidirectional one is made from just using 2 of the RGBs.
Yeah, right now it is.
Yeah.
I would have to look for a really old module, which I don't think I have access to find one with little discretes.
Okay.
I'm looking around. I'm like, where would I find one of those? Because it could be cheaper.
I mean, I think it could be cheaper. I mean, in terms of assembly, it will be slightly lower profile, I think, and it would be simple enough to assemble. So I wouldn't think it will. It's probably the lowest cost option. Okay, Rob, got that.
So I don't think I have any really old ones like that. I just have, red, blue LED is really an RGB LED here.
Yeah. Okay. Okay.
And then here's
That's 3.
physical
Yeah.
implementation of it as RGB.
Yeah. Okay. Yeah. It's the 4-terminal device. Okay. Well, let's go with the lower cost option if we can.
To me, I wonder, is it easier for these little modules for these little tiny LEDs to stay stuck down if it's one big fat RGB LED? That might be more robust.
Generally, the smaller the component is, the better.
Okay.
Yeah, I think that's the case.
Okay.
I think there wouldn't be an issue with either of these. We've done both 5x5mm and 0603s, and I don't think we would see any difference in terms of robustness.
Okay.
But we'll check the costs and confirm that one.
Okay.
Do you have any color preference for the LEDs?
What's that?
Sorry, say.
Do you have any color preferences for the LEDs?
Well, the bi-LED is usually blue for forward, red for backwards or short circuiting. And
okay.
Then for the RGB LED, we give people. Do you mean like, pick a frequency spectrum for the colors? Because if we look into, I can send you the exact part number that we use for the RGB LEDs from China.
Okay, that'll be good.
Okay. And I can even ask Brad if there's a bin of them in Austin.
Okay. Yep, that's useful. The buzzer, I think we decided last time, probably wasn't an option. I mean, Adrian did find a little 3-volt module, but pretty expensive at £3 and quite large. I think 5mm high or something. Adrian, it's quite chunky, wasn't it?
Yeah, it was pretty bulky.
So we assume that
no.
we don't do a buzzer.
Yeah. Expensive and annoying. It's the one thing that teachers say, we don't want a lot of these.
Right, okay, yeah. Makes sense. Right. Little NPN transistor, that's pretty standard stuff. Again, we could use the transistor you're using, I guess, would make some sense.
Maybe. I mean, I don't see these as being manufactured in the same factory.
No, sure.
Be manufactured by you.
Yeah, indeed. Okay. I mean, I think the 34p is pretty high cost. We may be able to find a smaller one. This was a really compact little package, but it might be that we can find a lower cost one because that is quite expensive.
DFN 2020, yeah. Okay. Right. We're getting the sort of SOT 2.3 version for like a couple pennies. With that.
Yeah, probably a few cents. Yeah.
I mean, we found it was cheaper to put more NPNs on the board than it was to include diodes and resistors.
Right, yeah. Okay. Use the transistor as a diode. Right.
Mm-hmm.
Okay. Yeah. Yeah, I think there will be a cost down activity at some point as well. Presumably once we've demonstrated what these things are like and how robust they are and how you get on with them. Then the next 3 lines are all a blinker unit, or options for a blinker unit. One built using a stable transistor circuit.
Mm-hmm.
One with a Schmidt, a small dual inverter Schmidt chip, and one based on an op-amp. The lowest component count, I think, was the Schmidt. Is that right, Adrian?
Yeah, that's correct.
Yeah. Probably not the cheapest. Probably the transistor version would be the cheaper one.
The Schmidt must require resistors and capacitors too, right? To keep it from vibrating really fast.
Yes, for sure. It has an RNC to set the time constant.
Okay.
And then it has LED on the output with load resistor. It's a little 6-pin chip, that one, wasn't it, Adrian, I think?
The spec inverter, yeah.
That sounds really cool. That's really cool.
Yeah, it's a nice little device Adrian found.
Mm-hmm.
Hadn't seen that one myself.
Okay. And then are you guys going to use Eagle for design, or what are you thinking?
We use
Altium.
Use Altium. Okay.
Yeah. If that's okay.
That's fine.
Yeah, that's certainly what we normally use.
Yeah.
So we've got 3 options ready for the flasher or blinker unit. Do you have a preference at all? Is it cost or is it?
It's cost. I would use the
cost.
Least expensive. Yeah.
Yeah.
The cost trade-off of least expensive and not going to be picked apart by a fingernail.
Yeah. So we'll check the cost and robustness.
Mm-hmm. / availability of the part. You know, if let's say you found like the magic part that did it all, but it's really hard to find, that wouldn't be awesome.
Oh. All right. So we'll compare those and come back with a recommendation.
Okay.
And then the final one is the power.
Yes, I know. Brett and I talked about this last week. Brett really doesn't want to use coin cells because you're not allowed to have them in every country. But we talked about using them because they're cheap. So I still think seeing both would be very useful.
So we sketched up, and this is the sort of size of a module. This would be a 3-volt lithium cell. We had a chat about whether it should be 3-volt or 6-volt. I mean, all of these printed cells are 3-volt or 1.5. So to get more, we're going to have to put them in series. But none of the circuits that are in none of the modules here need more than 3 volts. It would seem.
Right.
So this would be a 3-volt version. You could do it in 35 by 70 millimeter sort of slab.
That's good. Yep.
This is a 28 milliamp hour battery.
That is tiny.
Yeah. So that's about 1/10 of a typical CR 2032. They're typically about 200 milliamp hours or so. But that is about the best you can get unless you stack them. Or we look at some sort of custom battery.
I don't think we're going to go custom
battery. Are you guys
battery.
aware of sorry to interrupt. I was just going to say to the CPI team, if they're aware of regulations for shipping batteries, by air or importing into specific countries, if there's a threshold in actual energy or not, or capacity.
there is a threshold. I don't know what it is. Also, if batteries are in equipment, and it's questionable whether this is actually in equipment or not, then they can be shipped. So you can ship equipment with a lithium battery installed.
Right.
That's permissible. And these are low, but I don't know if they are as low. We did ship some recently, but I can't remember what the outcome of that was. But it is manageable. These are not lithium. Well, this is not a lithium-ion cell, so it doesn't come under the same regulations as this one, which is a lithium-ion. So this is a rechargeable printed cell. That shouldn't be 70. That should be 35, I think.
Okay.
This is lithium manganese, so it's a primary cell, single use. This one, and then there's zinc manganese, which is the other type that's printed commonly. They're 1.5 volt cells, so these would be 2 in series in a single pack. Again, sort of fairly low capacity, and the lithium ion, which are being produced, are lower again, but they are rechargeable if you provided a charging system for them. And then if you did go for a coin cell, it could fit in something like that on the right hand side here. You could attach essentially what you'd be doing here is attaching flexible tabs onto the standard coin cell holder that would then be attached down. Or maybe you want that as a temporary attachment, I don't know. So yeah, those are really the options that we could think of.
Well, I think since there isn't a lot of circuit design with these, this is just making a footprint and adhering batteries down. I think we should try both. And when I say both, I mean coin cell and flat. And then we need to decide, is the flat going to be a primary or is it going to be rechargeable? If it was going to be rechargeable, it'd have to have, let's say, like little alligator clip flaps on it or something for someone to be able to charge it over USB. And I just don't think that's really the use case we're going for.
Yeah, I mean, you'd have quite a cost in terms of the charger, and these are not safety protected, so you'd have to be cautious in terms of how the children could connect the lithium battery up. So I'd be a little bit cautious of that. I think the lithium manganese. I think these two are probably the best options you've got.
The biggest capacity and not rechargeable and possibly easier to ship, even though it's definitely not going to be in a plastic container that makes it more shippable. It's going to be a sticker, flexible at that.
Yeah,
I think figuring out, looking at the data sheet for that and finding out, is this shippable? And if not, what are the countries that it's not shippable to? It's got to be shippable within the United States.
Yeah.
Without having to use ground shipping.
Would you be able to look at that? I mean, we could send you the data sheets for that.
Yep.
Yeah. We'll send you the data sheet for one that we use quite a lot, which is sold by Rutronic, produced by Renata.
Okay.
If we send you that, it's probably safer if you look at that, because you would know much more what you're trying to do in terms of shipping. I think if we start looking into that.
Yep. Totally.
The link to the website sheets in the Excel for the Finchon battery.
Sorry, say again, Adrian?
The data sheet's already been linked on the thin film
Okay.
blockchain.
Yeah, there we go. Okay, this is the Renato one, yeah. I mean, they would be able to advise on shipping. I guess would be the safest thing to do.
Okay. Switzerland.
Yes. Yeah.
We will check on that.
But we will build one of each of these. Or we'll include both of these, coin cell and thin film lithium.
Okay.
In the set. Yeah.
Okay. And there's another module that we haven't talked about.
Yeah. We missed one.
It's something that I've been thinking about, and it's I don't know if you want to call it a module. It's more like a sticker that sticks up like a shark fin that you could grab with alligator clips.
Okay.
I think that would be a useful sticker module. So that makes it easier to bridge between, to a different part of the electronics ecosystem, like over to Makey.
Yeah, yeah. Okay. So purely a external connection module or something like that.
Yeah, I mean we could just code name shark fin. External. 1 or 2 tabs. Yeah. Maybe it's just one.
Just one, even. Right, okay.
Yeah. Maybe it's 2. Maybe it's better if it's 2. The same footprint spacing as all of our 2-pin modules.
Yeah.
But yeah, I mean, maybe it's outside of the scope for us to add that, but I just think that that is a very easy one and that we should do it.
I think we can include that one, I'm sure.
Okay, cool.
That's feasible.
I mean, I think that'll be really useful for testing.
Yeah, yeah. Because you can get some very nice flat crocodile clips that are not toothed, but make nice connection to these sort of things. We use them quite a lot.
Okay.
Okay. Right. I think that's given us a few actions to investigate and finalize what we would suggest for the set.
Okay.
And we'll do that over the next few days and come back with the, if you like, the list of the sheet, the list of the modules and how they'll be built and what their function will be. Okay. Just extensions of this table really, or maybe simplifying this table down a bit.
Okay. Different tab in the table says,
yeah.
Moving forward, these modules will be prototyped.
Indeed. So these are the yeah. That's a good way of doing it. We'll add a new sheet that is the modules that are actually going to be built.
Okay. And then I suppose this will take a while. You'll have to order components and do some testing, and then print them out. So when do you want to meet again?
Well, we'll come back with the list that we're going to build.
Okay.
And we can probably just do that by email unless there's something that we need to discuss.
Sure.
We can just send that list through.
Send it over and Brett and I will discuss it.
Yeah.
Okay. Melb's too.
We,
if you
we
want.
can then get on with the design. So tell you what, should we leave let's see how that progresses. We can set up a meeting either next week if it's useful, or probably the week after would be more sensible, I'd have thought.
I think so.
Um,
That sounds very reasonable. Next Monday is a holiday in the U.S. also, just FYI.
okay. Right. So let's aim for this time, Tuesday the 15th.
Okay.
This time on Tuesday the 15th.
Sure.
Yeah. The next call, and by that point we'll have decided what's being built and have some ideas of what they look like, I think, by that point.
Okay. Sounds good.
Great. Okay. Well, if there's no other questions or points,
Did
can
you
leave
guys
it there, I
get
think.
the access to the Dropbox? Were you able to get in?
Yep. I received the email this time.
Okay.
And,
Yeah.
Has anyone clicked on it and tried to get in?
Yeah, I
it's
did it
there.
now. Yeah.
Okay, great.
Yeah.
Great.
Yep, that's excellent. Thanks for that.
Yeah.
Good. All right. Okay. Well, good to see you again, Rob.
You too.
And thanks for your time.
Thank you. This
see
is
how
exciting.
we
We'll
can
talk to
progress
you in a
this.
couple of weeks. And if you send off the list, Brad and I and Melbs will go through it.
Excellent. Good. Okay. Okay. Speak to you soon then. Bye for now.
Okay, bye. Bye-bye.
Thank you very much.
Guys, bye.
Yeah.